Hello everyone, I'm Gay Hill and I am in Grail Mission Control. We are with the team for its last half hour with the spacecraft, and Ebb and Flo are now out of fuel and they are on a deliberate collision course with the moon, and they will impact the moon at approximately 3,800 miles per hour. For Ebb, the impact will take place at approximately 2:28:46 Pacific time, and then for Flo about 20 to 30 seconds later at about 22:29:14, give or take a few seconds. We're going to spend the next half hour talking to team members about this project and what it's been like, beginning with David Lehman. He is the project manager of Grail. First of all, let's talk about the last big event, the burn. That happened about 20 odd minutes ago. What happened at that time?
Well, about 20 minutes ago, as you said, we just finished the burn to depletion on both spacecraft, both Ebb and Flo. And you can see the display up there, which is the Doppler signal. And it shows that on the Ebb spacecraft, the amount of fuel remaining was equal to approximately 20 meters per second. And then on Flo, the remaining fuel was equivalent to 25 meters per second.
Now, why was it necessary to do this experiment, this exercise? You wanted to gain information right down to the very last.
Right. What we wanted to do is we're going to use this data to compare with estimates of what the fuel remaining is. And so it's very rare for a mission to be able to do a burn to depletion. That tells you exactly how much fuel is remaining. But we're going to use that data to compare to the estimates the engineers have, and then we can use that to better manage future missions.
To help other missions.
Right.
Tell me why we decided to end the mission this way. Why not just let the fuel be done and land wherever?
Well, on the moon, there are about 23 heritage historical sites. And these are sites where either the U.S. or the Russians have a soft lander. And the NASA policy is not to disturb those sites, to stay outside of 2 kilometers. So we wanted to miss those sites. The other thing is we wanted to know exactly where we landed or where we're going to crash. And so we're coming up from the south, and we want to get good tracking data of the final moments, and then we're going to crash on the northern hemisphere of the moon. And so we wanted lots of data, tracking data, to know where we actually crash.
Now we have visuals and animation showing exactly the trajectory of the 2 spacecraft. Walk us through what will be happening, and we can actually see that animation, and we can go ahead and take a look at it. It will start on a globe view. Here we go.
All right, so this is Ebb and Flo. The one leads the other by about 20 seconds, and they're going to be coming up from the southern hemisphere, and they're already about halfway there right now. And about at 2:28 p.m., we're actually going to do the impact on the moon.
And there you have it. And tell me why to this location, that it's going to be in darkness. We won't be able to see anything, will we?
We won't be able to see anything because it is dark right now on the moon. But we picked this site to make sure that we did not hit the historic sites, the heritage historic sites, and we wanted to get good tracking data before we impacted. And so it turns out that this mountain in 75 degrees north latitude is where it fell out, where we're going to hit.
Perhaps we won't be able to see it right now, but LRO is orbiting the moon. Will we be able to get information later on?
Yes, LRO has already imaged this site in detail. We have lots of data on where we're going to impact, and then in a couple weeks, LRO will fly over it again, the Lunar Reconnaissance Orbiter, and we'll get more data on what we'll see.
Will it just be looking at it with optical sort of instruments, or will it be looking at it in infrared? What sort of instrumentation?
They have a full spectrum of instruments, so all kinds of spectrum they'll be able to image.
Well, overall, looking back at this mission, you said yourself that you would have mixed feelings today. Why is that?
Well, we launched 15 months ago. These spacecraft are very well behaved. What I'd like to do is continue on for another 6 months, but that's not going to happen. So it's pretty much a sad day for me. And in fact, I'm wearing, usually I don't have handkerchiefs with me, but today I brought my handkerchief just in case.
You're going to be ready. But this mission has surprised a lot of people. It's gone well beyond what everyone's expectations were, have it not?
Yes, we've all of the data we hope to have gotten scientifically. We've gotten over 99.99% of the data available we have, and the team's done a great job, and we did it on schedule and under budget.
All right, so we're not too far off in the big moment. Thanks for helping us out, Dave. Right now, we're less than 25 minutes away from impact. Again, the time is 2:28 Pacific time, 5:28 Eastern time. And since the very beginning, this mission has always been all about the science. Now, the spacecrafts were flying at about 55 kilometers over the surface, and they were able to return the best gravity map ever of any celestial body. And then for an encore, the twins went ahead and went even lower. Here's a look at some of the accomplishments of this mission.
3, 2, 1, 0, and liftoff of the Delta II with Grail. Journey to the center of the moon.
When Grail launched, at that point, I was hoping we would get those two spacecraft in orbit around the moon.
We have Grail A break wire and separation. Good separation. Grail A now flying on its own.
Okay, all stations, Grail A systems on Grail A cord. At this time, the reconfiguration of the spacecraft for the post-LOI configuration has begun, and rearming of fall protection and configuring heaters to their correct settings.
Yes, we're in orbit. We look like we're in a very nominal orbit.
Things have gone as well as they could possibly have gone. Neither spacecraft has had an upset that has caused it to go into safe mode. We have not lost any data. We have essentially collected more than 99.99% of the data. So in both the quantity and the quality and the spatial resolution of the data and the amount of data, everything has exceeded the expectations that we had for the mission. One of the biggest surprises that we've found so far is evidence for very long dikes or intrusive features within the crust that are not observed at the surface whatsoever. We now believe that the moon heated up enough to expand, and that this occurred extremely early after the moon formed. We now see evidence for this. We have found with the Grail data that the crust of the moon is even thinner than it was believed to be. And so this provides us with information about how much early melting of the lunar exterior occurred and how much of the outside of the moon melted. So it tells us something about the thermal history. But it also tells us about how this melting was distributed over the surface of the moon, and we've been able to map this out. The idea that one can map a planet from orbit at the height, similar to what a commercial airplane flies around Earth, just opens up huge possibilities of really studying the shallow structure of the moon. Our team is absolutely delighted that we now have the data set that is going to allow scientists to study these fascinating questions for years to come.
Okay, we have scooched over to Maria Zuber's spot. She is the principal investigator. She's standing by, watching all this information come in. You yourself said in that video piece that it exceeded all your expectations. This has gone as well as it possibly could have gone.
It's actually hard for me to envision what more could have happened than has happened. We wanted to fly low, we flew low, and we learned enough by flying low that it was possible to challenge the team to fly lower and then lower yet.
Let's go over some of the scientific accomplishments of its prime mission. What did you discover?
Okay, so the analysis of gravity is very complicated, and so the initial results have only just come out. But the first results have shown that the moon was heavily fractured in the exterior. Now, we knew from the bombardment in the early solar system that fracturing of the outside of planets has occurred. This is something that we call the planetary regolith. But what we've been able to show is that this fracturing is much more intensive and extends much deeper into the crust than we had ever thought of before. And in fact, that this kind of fracturing must have occurred on other terrestrial planets as well. So because fractures provide a pathway for volatiles, this is going to tell us things about the formation of early atmospheres as well as the possible transport of volatiles between the surface and the interior. We've also learned things about the early expansion of the moon by the determination of large dikes that have not been visible at the surface. They were predicted by models, but any record that might have been at the surface would have been wiped out. We've determined the thickness of the lunar crust. Finally, we have a crustal thickness model of the moon globally that matches the point measurements that have come from Apollo seismics. And this shows us that the moon's crust is actually much thinner than we thought before.
We have actual image of the animation of the gravity map, and we can play that while I talk to you a little bit more about this. How are we going to use this information? This is information that scientists have wanted for a long time.
Well, this, yes, I mean, this will be used to study geophysics, to get at the structure of the moon, the early heat flow of the moon. But this data will be a boon for geochemists, petrologists studying the composition of the moon. What's been very apparent so far is just what great interest this data is for people who study lunar samples. So we continue to study the lunar samples. We continue to learn things. But what was actually very exciting was our density values for the moon and how well those compared with the point values from lunar samples that were collected from the moon 40 years ago.
And speaking about learning from this information and learning from the moon, one of the aspects of this mission is outreach to middle school students to learn about science and to be excited about science. Talk to me a little bit about MoonCam. And we have footage from the MoonCam cameras of a flyover over the surface.
Okay, well, we are extremely proud of the MoonCam investigation, which is the first time an imaging device has actually flown on a NASA spacecraft and been totally dedicated to education and outreach. So the MoonCam program enlisted over 200,000 students, over 3,600 classrooms from the U.S. and actually 63 countries. And students have targeted over 100,000 images of the lunar surface, which are all posted online. We've extended the funding of the MoonCam investigation in order to develop more exercises to study the images so that these images can be used as a resource for years to come for teachers who are interested in teaching students about the moon, something that goes beyond just learning what the phases of the moon are.
So it'll be archived there for future students to learn.
Exactly.
All right. Maria, I know you're standing by. Thank you so much, and we'll talk to you a little bit later. Sure. Meantime, let's talk about some of the first students who ever used MoonCam. They were fourth graders from a school, Emily Dickinson Elementary in Bozeman, Montana. They were the kids that named the two spacecraft. They named them Ebb and Flow. And remembering back that day when they made the announcement is one of the highlights of this mission. Take a look back.
We gave these two spacecraft names of A and B. So we asked the youth of America to assist us in getting slightly better names, and we held a nationwide contest. Over 11,000 students wrote essays. There was a very competitive competition.
GRAIL is the first spacecraft mission to carry instruments that are entirely dedicated to education, cameras that will be operated by students. And it's my pleasure to introduce fourth grade teacher Nina DeMauro. Her class at Emily Dinkinson School submitted the winning entry. Nina, congratulations.
We're so thrilled that our names were chosen. Give me an E! Give me an F! Give me a B! Give me an L! Give me a B! Give me an O! Give me an N! Give me a W! What have we got? Can't hear you!
And that was one of the very special moments of this mission. With me right now is Dr. Charles Alachi. He is the director of the Jet Propulsion Laboratory. JPL manages the Gray mission. And tell me a little bit about your feelings about the success of this mission.
Yeah, I mean, first, no question, we have mixed feeling about it in the sense of when you work these missions for so many years, they become like part of the family. So people do feel, the angst about, the end of the mission. On the other hand, it is a celebration because this mission have accomplished tremendous science. It was superbly well managed. It did things on schedule and well within the budget that was committed to NASA. It's improving our knowledge of the moon literally by orders of magnitude on it. So clearly it was one of the greatest success that we have in space exploration.
And even from an engineering standpoint, we're learning from this that the burn to depletion will give us information that will help us for future missions.
Absolutely, and I mean the team is using every possibility and every opportunity to improve our future prediction for future missions. And the knowledge of the gravitational field is now so accurate that it will enable us in the future we fly mission, be it NASA mission or possibly commercial missions in the future, we will be able to navigate much more accurately about where do we land and how we fly over the moon.
That would also apply to manned missions as well, having such an accurate map this way.
Yeah, absolutely. I mean, it's the same thing as here on Earth that we have the GPS network, which allow us, to land airplanes very accurately. This one enables us not because of GPS, but because of the knowledge of the gravity field. It will allow us to navigate both human and robotic mission to land, basically do pinpoint, landing on the moon. And for future exploration, that will be very important.
So with this success behind us, what do we look to the future for?
Well, the future also looks very good. I mean, NASA is very committed and our country is committed to keep leadership role in planetary exploration, being the moon or the planets. As you know, after the landing of Curiosity, which attracted literally 50 million people who were watching that landing, and NASA decided to lay out a new plan for Mars. So we have the mission InSight, which will be landing in 2016 to look at Mars quakes and learn more about the internal structure of the moon. And recently NASA announced a 2020, Mars rover mission that will take us the next step in exploration of Mars. We have the Juno mission, which is heading toward Jupiter, which will give us insight about the internal structure, of Jupiter. And there is a whole series of missions that our country will play the leadership role in planetary exploration. So we're all excited, about that combination of missions.
Well, Dr. Alachi, never a boring moment here
Absolutely
at JPL.
Not.
All right, thank you for
very much.
joining us. Well, JPL is not alone in the operation of the Grail mission. We are also partners with Lockheed Martin Space Systems in Denver, Colorado. And we spoke to some of the team over there, and like the folks here, they're looking at this moment with mixed emotions.
Operating the two spacecraft here in the mission support area at Lockheed Martin has been very exciting.
During the extended mission, we've been doing maneuvers extraordinarily frequently, a few maneuvers a week. With flying two spacecraft at the same time, it adds some more complexity to attitude control.
The Grail extended mission has been slightly different from the primary mission, that it is a little bit more sporty. We knew that going into it.
What we've been doing is flying over the moon's surface so low. And as we fly, we've been going down into basins, and then we have to do maneuvers to pop us up over the ridges that follow those basins. And so it's been constantly these 3 maneuvers a week to keep us from crashing into the moon.
The two spacecraft have behaved remarkably. So it's actually made our jobs a lot easier, not having to constantly deal with anomalies or investigate problems.
We've been flying low over the moon for this extended mission in order to get high precision gravity data. And it's the most high precision gravity data that's been measured at the moon to date.
Ending the GRAIL mission, coming to an end, there's definitely a lot of mixed feelings. Personally, I am excited, but it's also kind of sad because it's been a huge part of my life and the entire team's life.
To have gotten to fly a complex mission and do things that no one has done before with this kind of spacecraft. Doing all these maneuvers in a week, just avoiding the terrain by flying down into basins and up over ridges. It's been an honor, and it's been an incredible mission.
Part of the team here that works hand in hand and works a lot with the team at Lockheed Martin is our navigation team. And with me right now is Sarah Hatch. She's a trajectory analyst, and you're a member of the navigation team, which is right down the hall from us here.
Yeah, they're right down the hall.
They're watching closely. Why don't you tell us exactly what the nav team does?
Well, there's about 20 people on the GRAIL nav team over in the room down the hall. And we have several different functions. As my job as the trajectory analyst is to figure out where the spacecraft needs to go to satisfy all of its science requirements and communication requirements. So we plan the path. The other analyst, Mark Wallace, and I have planned out these 78 maneuvers that GRAIL has gone through, and we plan the path. The other part of that is the orbit determination. They figure out the data that comes in, figure out where we are along that path. Most likely we're not exactly on it. So what we do then is have the maneuver design team design the maneuvers. So the trajectory people say this is what the maneuver should do, but since we're not on that path, the maneuver is going to be different. So they design the maneuver, pass that off to the folks at Lockheed Martin to implement it on the spacecraft. So the spacecraft points in the right direction, burns for the right amount of time to get the change in velocity that we need.
Speaking of the burn, we're looking at the Doppler here. Can you walk us through what's transpired since the burn, and how did the burn go?
The burn went great. We actually burned a little longer than we expected, so we had a little bit more fuel in the tanks than we thought we had, which is good news, and it will help the Lockheed Martin folks a lot in determining how much fuel is on the next mission. We burned for about 4 minutes on GRAIL A, Ebb, and just over 5 minutes on GRAIL B, Flow. And as the Doppler came in, we were kind of walking up that line. There was a maximum possibility, and way out there, maximum possibility of 55 meters per second. GRAIL A was just over 20 meters per second. GRAIL B was just over 25, almost 26 meters per second. So they went really, really well. The data is coming in, and our team back in the other room is analyzing that data and getting updated estimates on where we're going to impact on that crater ridge.
Quickly, we have one of the displays that the team has come up with. Walk us through as to what we're seeing. We're seeing a blue line and a red line that indicates ebb and flow and where they're targeted.
Yes. If there were to be no burn to depletion maneuver, we would have ended up on that kind of red contour there, more to the right. Because we did those maneuvers, we moved to the left, and we also moved down on that crater wall. So you can see there, the A line is, or the red line is GRAIL A, Ebb, and the blue line is GRAIL B, Flow. They're approximately going to hit about 3 kilometers apart, and they're about 32 seconds apart in impact time. The impact times are very close to what we expected them to be because our delta V's weren't too far off from what we expected. And so that's where they're going to impact on the mountain. And as the data comes in, there'll be a little dot that moves along to kind of show where the spacecraft are. On the bottom part is kind of a cross section of that mountain and some downstream topography. And you can see there's kind of a little ridge south of our impact location that we design these maneuvers not to impact there. And so we skip over that mountain and then impact the crater wall.
So it looks like we're clear of the ridge?
Yeah, it looks like we're pretty clear.
And we're right on target.
Yep.
All right, Sarah, thank you so much. I don't know if you heard, but we heard the call just a little while ago that we are 5 minutes away from impact. And because of that, we are going to head over here to Glenn Havens, and Glenn is the Deputy Mission Manager who is going to walk us through and tell us exactly what's happening with this impact, play-by-play. Tell us what's happening so far.
Well, we just crossed about the 5-minute mark. It was just called out on the net. So all the teams now are basically watching the Doppler display. So the Doppler is two-way data that we're getting from each orbiter. Our stations that are tracking here, in this case from Goldstone, California, are sending signals. We get those back, and it basically shows us that the spacecraft are alive and acts as our heartbeat right now. So we're watching these signals, watching this green line get closer to the time we expect the impact. When it reaches that, we expect that signal to go away, and that's going to mean that the orbiters have impacted on the moon.
And give us the time now. We are, what, just
So we're
3
about
minutes
3
out?
minutes and 17 seconds for Grail A, and then Grail B is just about a half a minute later.
So what are you looking most closely at then?
Well, I am watching this Doppler data and watching it track, and you can see the lines have appeared here on this cross section of the topography. So one of the things we're waiting for is just to see that signal pass over that ridge that Sarah just told you about. That'll show that we cleared it, which we expect to. So we're right on trajectory, and now it's just waiting.
All right, so
Yeah.
we'll be standing by, and as soon as you hear the call out, let us know.
I will. So about 2.5 minutes for Grail A.
Hey, Dad, can you stand up for now? Can you stand up for now? And then put that chair there so I can whip around if I need to. Thank you. That makes sense? Okay. No, because if I whip around, I'm going to go that way.
Okay, so 2 minutes for Grail A until impact.
Yeah. You don't have to. It's fine.
We can see the signal here approaching the ridge, so we're getting closer. Just about 1 minute and 20 seconds for Grail A. Grail A's passing over the ridge.
All stations, this is Grail A Systems. We are now at 1 minute to impact.
Systems has just announced over the web that it's 1 minute. Nav confirms Grail A has made it over the ridge. Now we can see Grail B is passing over the same ridge. So I'm kind of waiting for the call from Nav that says they've made it successfully.
All systems, Grail B passed over the ridge.
And Nav's just reported that we successfully navigated Grail B over the ridge, and now we're on target for our impact. Grail A impact in 20 seconds.
Systems copies, and all stations, Grail B systems, we are less than 1 minute to impact.
It's getting closer.
All systems, this is Grail A Systems. Impact in 3, 2, 1, 0.
So Systems has just made the call from Denver that we hit the time where we've impacted.
Grail A, station 7.
7 Grail A's, go ahead.
222851, we have lost signal.
So the DSN station has just reported that we've lost signal for Grail A. Grail B is just about 4 seconds.
We have lost the signal.
Off at this time. And all stations, Grail B systems, we have passed the point of impact.
Grail B is past its impact time.
And station 27 has drive off.
Okay, and then we just have the report from the DSN that we've lost signal for Grail B as well.
Grail 8 station
So both spacecraft are now
All stations,
on the
Grow B
surface of the
Telecom.
moon.
We have lost signal with Grow B.
Well done.
I'm going to make a call.
Good way of ending. Now, don't do the same on the next one. We want that one to next one.
We've met before.
Good job.
Yeah.
Okay, if you want to go stand next to Marie. Okay, you'll be over here. If you'll stand.
Grail A Systems, Grail B Systems on Grail A Cord. Grail A Systems Mission Manager.
All right, it's a moment of celebration here in Grail Mission Control. Let's go back to Maria Zuber, and we have an announcement to make, I understand.
Yes, we do. Well, I'm extremely happy to announce that NASA has approved the Grail team's request to name the final resting place of Ebb and Flow after our teammate Sally Ride. Sally was a visionary, the head of our MoonCam investigation, and the team very much wanted to honor her contributions to education by naming the impact sites after her. We know that NASA has plans for celebrating Sally's accomplishments in many different areas, but her contributions to education in Grail and more generally to science, technology, and math education are very, very special to our team. So we're very happy to be able to do this for her today.
And we'd love to get some reaction from Reverend Bear Ride, sister of Sally Ride. What are your feelings about this?
We are so deeply appreciative and so thrilled. Speaking for the whole family, we're so grateful to Maria and to the team for continuing this dream and making it such a complete success. Sally comes from the generation of kids that watched the Apollo and got excited about science in that way, and then after becoming an astronaut and actually having that thrill herself, she really gave herself to igniting the excitement and curiosity about science to middle school kids, especially girls. So it's really cool to know that when you look up now at the moon, there's this little corner of the moon that's named after Sally, and we hope that kids will really be inspired by that as well.
Well, Bear, thank you so much for being a part of this. Let's go back to Maria one last time to get your final thoughts.
I guess I'd just like to close by saying that Ebb and Flow have removed a veil from the moon, and removing this veil will enable discoveries about the way the moon formed and evolved for many years to come.
Well, this has been so much part of your life, and you'll still be working for quite some time with all that information trickling in all this time.
Yes, we will.
All right. Thank you, Maria. Well, this is wrapping it up here from Grail Mission Control. We have impact both spacecraft, and from now on, not only will we see the resting spot for the two spacecraft, but we will also see it as a memorial to Sally Ride, America's first woman in space. So that wraps it up here from Grail Mission Control. I'm Gay Hill. Have a good day.